there are you can perform certain algebraic manipulations on the series. For example, if we have two series that are Bott converged, we can add or subtract them like we normally would. In general, if we have two series that are Bott converged, so if I have something that converge plus or minus something that converge, then we would also get something that converge. However, if we have something that converge plus or minus something that diverge, then we are also going to get something that diverge. However, if we have two things that are both converge, being add or subtract, so diverge, add or minus diverge, then we don't know what we are going to get in the final case here. And also, if we have a series that are converged, then we can multiply a constant to that series, so we can pull a constant out of the sum basically. But if I have a sum that diverge, then if I multiply a constant, a non-zero constant to that sum, then it will remain diverged. For example, if we look at this guy here, 1 plus 2 to the n over 3 to the n, now then I can see this as just the sum of 1 over 3 to the n plus 2 to the n over 3 to the n. And I can split this guy into two sums now. So this is going to be just the sum of 1 over 3 to the n plus the sum of 2 to the n over 3 to the n, where 2 to the n over 3 to the n is just the same as 2/3 to the n. So now I have split this guy into two geometric series, and I knew how to find the sum of these two guys. The first guy is just going to be, the first term are going to be 1 minus 1 over r, which is 1/3. Notice how r is less than 1, so I can use the formula. And the sum for the latter guy is going to be just the first term, which is 1 again, minus 1, over 1 minus 2/3. So now I can compute the answer. This is going to be, let's see, 1 over 2/3, so that's going to be 3/2, plus 1 over 1/3, so that's going to be 3. So these two things add up to 4.5. So I knew that for my part A, this guy is going to converge. It's going to converge to 4.5. Okay, for the second guy, notice how if I actually split this into two sums, so I'm going to get the sum of 1 minus the sum of n over n. The sum of n over n. Now, n over n is going to just cancel out, so I'm going to get the sum of 1 minus the sum of 1. With n goes from 1 to infinity, but about this guy diverges. So this guy diverges. This guy diverges. This guy also diverges. So this actually now belongs to the last case here. If I have something diverge plus or minus something diverge, then I can't really conclude what's gonna happen. So that means I actually can't split this into two summations like this, because I get two things that are both diverge. So let's actually go back to the summation that we have. Notice how I can actually simplify the thing in the parentheses here. 1 minus n over n is just going to be 1 plus 1, which is 0. So here, I'm looking at the sum of 0 from 1 to infinity. So this sum is just a sum of a bunch of 0. So it doesn't matter how many 0 we add up, we are going to get 0. So this guy is going to converge to 0. So what this means is, if we split the sum into two things, but both things diverge, then we can't really conclude anything we can't really conclude anything after the splitting. We actually have to go back to the original sum, and maybe we have to work out whatever we have in the sum in each term. Now the next one is something we have seen already. We have 9 over 10 to the n. Now we can actually pull out the constant 9 here. So this guy is going to be the same as if we pull out the number 9, it's going to be 9 times the sum of 1 over 10 to the n, where my n goes from 1 to infinity. So my series here, this is just going to be a geometric series. So this is going to just equal to the first term, which is 1 over 10, divided by 1 minus the ratio, which is also 1 over 10. So I'm going to get 9 times 1/10 over 9/10. So eventually the whole thing is going to get cancelled out. So this is going to just equal to 1. So this guy converges to 1. Now for the last guy, I have the sum of 3 over 5n, where n goes from 1 to infinity. Notice again, I can actually pull out just the constant, so I'm going to get 3/5 times the sum of 1 over n, where my n goes from 1 to infinity. And this series, this is just the harmonic series, is the p series when p equal to 1. So this guy diverges. If I multiply something that diverges to a number, just 3, 5, then it's also going to be, it will remain being diverged. So this guy, for my last part, is also going to diverge. Okay.